Welcome to Lesson 216, Equivalent Ratios and Graphs. Today we're going to talk about how to create a graph using equivalent ratios, how to find equivalent ratios using a graph, and to solve problems involving equivalent ratios using a graph. Alright, so if we have a problem that looks like this, Jake collects 12 new coins each year. Use equivalent ratios to graph the growth of his coin collection over time. So we have to find the important information here. We know that he gets 12 new coins and then each year. So we know that our ratio of coins to years is 12 coins to every 1 year. There's lots of important parts of graphing. The first important part is making sure you have labels and appropriate intervals. So in this case, if I'm going to put the time on bottom, and I'm going to move this up a little bit so we have some space to work. I need to write that I'm putting years on bottom. And then on the side, I would need to label it as coins. And I would probably write number of coins. And I'm actually going to type that so it's a little bit easier to read since it's sideways. But we always have to have those labels. If you don't have labels, your graph doesn't make any sense. Even if your data is completely correct, your graph is still incorrect because we don't know what goes with what. Okay, so then in this case, when we start to label, since we go up every 1 year, it would make sense to just go by ones when it comes to years. So 1 year, 2 years, 3 years, 4, 5, 6, 7, and we don't have to do all of them. At this point, it's pretty much assumed that it continues to go up by 1. And I'm going to go up to 10. Now on this side, because the number of coins goes up by 12 every year, we could just go up by 12. So I can say 12 coins, 24 coins, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144. Okay, and I'm going to stop there. All right, so now what we need to do is we can make a table to help us make equivalent ratios, or we can just start to create our equivalent ratios, but we have to know what our ordered pairs are. So remember, it's x to y. Since our x is years, my first ordered pair would be 1, comma, 12, because I'm going over 1 and up to 12. Okay, and then I know my next equivalent ratio could be 24, so I multiply 12 times 2, and then I multiply 1 times 2. So my next, because my y is the years, that's what has to be listed first. So my y in this case would be 2 years, and my x would be 2 years, and my y would be 24 coins. So I go over 2 years and up to 24 coins. So I'm using these equivalent ratios to help me figure out what my ordered pairs are, and then I'm graphing them. Essentially, when you're making a graph, you're just making ordered pairs in just quadrant 1, typically. Now, if you have a graph that's using negatives, you're still graphing in one quadrant, but it's the same idea as using ordered pairs. You have to figure out how far over you have to go and then how far up. So again, I can multiply each of these by 3 and get 36 to 3. So my x coordinate would be 3 years and my y coordinate would be 36 coins. So I go over to 3 years and up to 36 coins. Okay. I'm starting to see a trend here that because it is 12 to 1, whatever my x coordinate is, it's just going to be, my y coordinate is just going to be that times 12. So I know that 12 times 4 is 48. 1 times 4 is 4. And I know that ordered pair would be 4 and 48. Go over 4, up to 48. Right, so now that I'm starting to see a trend, I can use a ruler, but since it's easier for me just to use my line tool, I'm going to use my line tool. And you can use a ruler and a pencil, it'd probably be better for you. And we do want to start at 0. So if we have 0 years, we would have 0 coins collected. Okay, and then we start and we go through the middle of each of these. Now, I want to go past just to kind of show what my prediction would be. And then typically what we like to do is we like to put an arrow on here to show that it would continue to grow upward. So what we did here was we took and made our own ratio. And after we made the ratio, which was 12 to 1, we then created our equivalent ratios and turned them into ordered pairs. Now this is where it's really important to make sure that you have your ordered pair listed correctly, because years is our X coordinate and coins are our Y coordinate. It has to go years and then coins, whereas in our ratio it goes coins and then years. So you have to be very careful and watch what you're doing. Okay, and we always have to have a title. So the title of this graph could be, let's say, Jake's coin growth per year. Okay, because we want to show that it's the coin growth, which it is, and we want to show the time frames that we're kind of looking at. So we're looking at it per year. Right, so next, we can look at another way to use the equivalent ratios in the graph. Andrew puts $20 in his savings account every month. Create a graph using equivalent ratios to show the growth in his savings account over time. Okay, so again, we have to make sure that we find the important information, that we find the correct ratio, so we know that it's $20 every month. So if I write the ratio of money to months, it would be $20 to every 1 month. Okay, and again, I need to make my labels. Typically, we like to write the time on bottom, and in this case, time is in months this time. So I put my label of months down at the bottom, and then over here, we put money in savings account. And we want to make sure that we show that it's in dollars. Okay, because we could be doing it in pesos, pounds, so you need to make sure that you're showing whoever's reading it that you're using dollars. And just putting a dollar sign or writing the word dollars will work just fine. All right, so in this case, we have to, after we do our labels, we have to make our intervals again. Again, this would be fine to go by ones since we are using just 1 here. So we could go 1, 2, 3 months, 4 months, 5 months, 6 months, 7 months. And we can stop there. Okay, and then the next one, we can look and see it's $20. So I can go up by 20. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay, and I'm going to stop there because at that point we've established that there is a pattern. Okay, so if I look down at the bottom down here though, I can see that it says, how much will Andrew have saved in 24 months? Well, if I leave my graph the way that it is, there's no way that I will be able to show 24 months of growth. So what I need to do is I need to think of a way to make 24 months fit on the graph. So instead of going by 1, I'm going to choose to go by, well, if I go by 2s, I can go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that will fit. So I can go by every 2 months. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so now Sometimes you have to look at the second part of a question to make sure that your graph is going to help you answer that question. So now in this case, I could graph 1 month and $20, but I'm going to end up plotting it in the middle of a grid. So I don't necessarily have to use that. And I'm also going to show you how to use a table to make your graph. So in this case, we can use the shape tool, or I can use the shape tool. You'll have to draw your own table. And then split it apart. Okay, and it doesn't have to be that perfect, just so it looks like a table, and so that way you stay consistent with what you have on top of your table. So if we put months on top and money on bottom, we have to stay consistent with that. See, this table isn't the prettiest thing, but it will work for what we need. All right, so then what we can do is we can say, all right, well, I know that I'm going to do, to try and stay consistent, because I usually like to put my X on top and my Y on bottom, I know my X coordinate has to be my months. So in this top column, I'm going to put months, and in the bottom, I'm going to put money. So now, if I have 1 month, I've saved $20. Or, well, Andrew has saved $20 because he's put $20 away. So now I can say, well, if I do 2 months times 2 times 2, it's 40. I know I need to get up to these numbers up here, but I'm also going to show you how to find the answer without actually graphing it, with using the graph to figure it out. So we're just going to keep kind of going up by 2. So if I multiply, I can multiply this by 4 and this by 4 and get 80, or I can just go back and say times 2 times 2. Okay, but I'm going to keep going back to my 1 month, so I'll have 6, so times 6, and then times 6, times 8, times 8, times 10, times 10, times 12, times 12. Okay, and then times 14, times 14. And how I do this easily in my head is 14 times 2 is 28, and then I add that extra 0 from the 20 at the end. So now I can go ahead and use these to graph my graph. So I can use 1 and 20. And I don't have to write out all the ordered pairs, but I do want you to see that this is how the ordered pairs would have to be written, because it has to go X, then Y. So I would have 2. So in 2 months, he would have saved 40. In 4 months, he would have saved 80. In 6 months, 120. In 8 months, 160. In 10 months, 200. In 12 months, 240. In 14 months, 280. So now we've hit the top of our graph. So as we're doing this, we can see that we have a trend occurring. We can use our line tool to draw that trend. Okay, so I start at 0. Okay, and again, I would extend it to show that it continues to go this way. Now, if I were asking you to tell me how much he earned in 1 month, okay, so I'm going to change, we're going to look at this, and we're also going to look at another way to find it. So if I were to ask you to find out how much he earned, or how much he would have in 3 months, what we could do is we could go over to where 3 would be. So in this case, 3 would be halfway between the 2 and the 4, so here. And I would follow it up until it hit the line. So I'm going to make a nice straight line here. So I'm actually going to use my line tool. And I would follow it up until it hits the line. And I see that it actually hits the line at $60. Now I know my line is a little bit off. Should be more like that. Apologize. So I know I can look and see, oh, well, in 3 months, he would have made $60 because that's where the 3 and this line meet. Same idea here. In 5 months, I would follow it straight up and see that he would have hit this line at $100. Okay, so we could do the same thing for 24. However, in this case, we can't use the graph because we ran out of space. But what we can do is we can look and we can say, okay, we can use the ratio and say that if it's 1 to 20, so if I multiply by 24, 1 month to 24 months, I know that 24 times 2 is 48, add the 0. So in 24 months, he would have saved $480. Okay, so you can use the graphs or you can use what you know about equivalent ratios to answer these questions. It's the same idea. Sometimes all they're going to give you is a graph to find these answers. All right, so what I'd like you to do is I'd like you to take a minute. I want you to read the question, take a minute, and I want you to try and solve. It wants you to use the graph to find the first 5 ordered pairs of Julie's cookie making over time. So you can choose to make your table first or try to graph first, but either way you need to be able to give me the first 5 ordered pairs. When you come back, we'll go over your answer. All right, so there's several ways that I can do this. I can say, well, I'm going to put my time on bottom, which is in minutes, and then over on the side, I can put number of cookies. Again, I'm going to type it just to make it easier for us to read. Okay. And then now here what I can do, if I've got the hang of this and I know that I'm going to do 30 minutes, 60, 90, 120, and then I know here I'm going to go up by 12 because that's how I make 12 cookies to every 30 minutes. Okay, and if I look, I know that that's correct. So I know that if I go 30 minutes, I would make 12 cookies. If I go 60 minutes, I would make 24 cookies. In 90 minutes, I would make 36 cookies. In 120 minutes, I would make 48 cookies. And in 150 minutes, I would make 60 cookies. Again, I want to draw my line so that way I can continue to use the graph to help me figure out how many cookies I would make without even having to plot points. Okay, so we have a good start, but now I need to know the ordered pairs. So the ordered pairs in this case would be my time, because that's my x, and then the number of cookies. So my first ordered pair would be 30, 12. The next one would be 60, 24, and then 90, 36, 120, 48, 150, and 60. 1, 2, 3, 4, 5. There's my first 5 ordered pairs. And I can double check by saying, okay, well, this is my original ratio, just turned around, times 2 times 2, times 3 times 3, times 4 times 4, times 5 times 5. Right, so there's all different ways that we can use the graphs or create graphs with our equivalent ratios. All right, so what I'd like you to do, I'd like you to read the problem. If the U.S. Olympic team wins 2 gold medals for every 3 events, make a graph that represents the equivalent ratios, then answer the questions listed below. List the first 4 ordered pairs that represent the gold medals won over events, and then how many gold medals will be won after 15 events. I know in some of the note packets this is 5. The 1 got cut out, so just change that to a 15. Right, so I want you to make sure that you list ordered pairs and that you're able to use the graph to figure out how many gold medals they would have after 15 events. As always, if you have any questions, please be sure to post them to Edmodo so that way we can go over them in class.